How's it going, everyone? In this video, we will show using math how hopeless romantics find love, and as a result, the majority of people do at some point eventually find a partner that they connect with. And we'll be doing this using what's called the binomial distribution, because in some ways the dating game is a binomial experiment, and I'll explain what that means. So if we have a hopeless romantic, they are two things, right? Well, they are, first of all, hopeless, okay? And we're going to represent that by saying that the probability that they find someone they connect with when they go out into the world, say they go out for the night, the probability is very small. And by very small, we're going to call that 1%. Now, people can disagree as to what a very small probability of connecting with someone is. Some will say it's a fraction of a percent. Some will say 30% is very small. We're just going to go with 1%. Now, not only are they hopeless, they are also a romantic, which means they just believe in love and they keep going out into the world and trying. So we're going to say that in 1 year, they go out 208 times. Now, where that number comes from is you've got 52 weeks a year, and if they go out 4 times a week, which is quite a bit, that brings us to 208. So the binomial experiment is one where something is attempted n number of times, like they go out 208 times, and each time ends in either success or failure, right? So they either meet someone or they don't. And the tries, right? The trials are independent, okay? So your success or failure the previous attempt does not affect your probability of success or failure the next attempt. And the two possible outcomes, success or failure, right, are mutually exclusive, right? You can't succeed and fail, right? It's either one or the other. And the probability of a certain number of successes is n choose x times p, which is the probability of success to the power of the number of successes, times 1 minus p, that's the probability of failure, to the power of the number of failures. Okay? So this first part here, right, that's n choose x, which is the number of ways you can arrange x successes out of n attempts. So for example, 4 choose 2, well, what's that going to be? Well, how many ways can you arrange 2 successes out of 4 attempts? And we can actually list them all right here. And it ends up being 6. So 4 choose 2 is going to equal 6. Now, I'm not going to go too deep into where this equation comes from, but there is a separate video specifically on the binomial distribution which goes into those details. So, if we have 208 attempts, and the probability of success during each attempt is 0.01 or 1%, well, the probability of one success is n choose x, p to the power of x, 1 minus p to the power n minus x, which comes to 208, choose 1, to the power, multiplied by 0.01 to the power of 1 times 0.99, that's 1 minus 0.01, to the power of 207, because that's the number of failures. Well, 208 choose 1 is 208. 0.01 to the power of 1 is 0.01. And 99 to the power of 207 is approximately 0.1249. All right, and when we multiply all of that together, we get about 0.26, which is 26%. Okay, so they go out 4 times a week, right? That's 208 times a year, and the chances that they meet someone is 26%, even though the chances of meeting someone any single time that they go out, each of those times that they go out, the chances is just 1%. Chances that they meet one person over the course of a year goes all the way up to 26%, which is much higher, but you might think, okay, well, that's still a 74% chance that they don't meet someone over the course of the entire year. But hold on. This is the probability that they meet specifically one person. What's the probability they meet 2 people? Okay, well, that's going to be 208 choose 2 multiplied by 0.01 to the power of 2 and 0.99 to the power of 206, right? Well, 208 choose 2, that turns out to be a huge number. 21,528. 0.01 to the power of 2 is 0.0001, and 99 to the power of 206, 0.99 to the power of 206, that's 0.1261. And when we multiply all of that together, because of that huge 21,528, we get 0.27, which is 27%. Okay, so the chances they meet one person is 26%. The chances they meet 2 people is 27%. That's already more than 50%. There's a higher than 50% chance that they're going to meet 1 or 2 people over the course of a year. Okay, so suddenly our hopeless romantic here has a reasonable chance of actually meeting 2 people that they're connecting with over the course of a year. Now, what are the chances that they meet 3 people? Now, we could keep on calculating this by hand, but to save us time, we can do it in Excel. So I've set it up here where we can put in the number of times they go out per year, our chances of success, which is right here, and the number of successes we're interested in, and this gives us the probability of that number of successes. So here's the result with 1, 26%. Here's the result with 2, 27%. And the function here, so combin, that's the Excel function for the choose function. It's called combin in Excel. We have n, choose x. We have, this is the cell with our probability of success during one trial, right? P to the power of n to the power of x times 1 minus p to the power of n minus x. All right, so if we put in a 3, 19% chance that they meet 3 people. Okay, so we've already had 26% chance that they meet 1, 27% chance that they meet 2, almost 20% chance that they meet 3 people, right? So our hopeless romantic can actually have a whole number of relationships over the course of a year. Now, once we start putting in 4, okay, 10% chance they meet 4 people over the course of the year. 5, okay, now we're down to 4%. Okay, but you see what's going on here. Because they're going out so many times, even though the probability of success during one trial is small, there's a much higher likelihood that they see substantial number of successes. Now, what if we want to know, well, what's the probability that they meet at least one person? Okay? So let's say they're not so greedy. They're fine just meeting one person. That's all they need. What's the chance that they meet at least one? Well, that's the same as saying, well, what's the probability that they meet not 0? Okay? And, well, that would be 1 minus the probability that they meet 0 people. Okay? So imagine if there's a 5% chance they meet no one, well, that means there's a 95% chance that they meet at least someone. Okay? So to find out the chances that they meet at least one person, well, we just find out the chances that they meet no one and subtract that from 1. So let's go to that spreadsheet. Let's throw in a 0. Well, the chances that they meet no one is 12%, which means the chances that they meet at least one person is 88%. 88. That's a very high likelihood. So our hopeless romantic, and let me show you that hopeless romantic again. There they are. Over the course of a year, there's an 88% chance that they meet at least one person that they connect with. And as we saw, they're actually more likely to meet 2 people than 1 person. Now, you might think, well, 88% chance, I mean, that's still not 100, but we only looked at 1 year. What if we bring it to 2 years? Okay, so 4 times a week, that's 208 times a year. Over the course of 2 years, that's 416 trials. So if we put 416 here, well, now the chances of meeting 0 people is 2%. And so the chances of meeting at least one person goes up to 98%. Okay? Now, that's 4 times a week over the course of 2 years. If you go 2 times a week over the course of 4 years, same result. Okay? And let's say we go 3 times a week. Maybe they're busy. Too busy to go 4 times a week, but over the course of 4 years, 624 times. If we go to 2 decimal places, well then, 0% chance that they meet no one. 100% chance that they meet at least one person. Okay, we got to add some extra decimal places to actually see things differently. Okay, 0.2% chance that they meet no one. 99.8% chance that they meet at least one person. That's going out 3 times a week for 4 years. So our hopeless romantic, as long as they stay romantic, they're not so hopeless. So if you ever wonder, how is it that most people eventually find someone? Well, that's how. And 4 years might seem like a long time, but from, say, 19 to 23, it's not that long compared to someone's entire lifespan. Okay? Now, the truth is, things are even more easy than that. Because one of the conditions of the binomial experiment is that the probability of success is not affected by the previous trials. Okay, the trials are independent. But in real life, with every trial, someone learned something. And there could be setbacks where the probability of success drops down for a period of time. But generally speaking, as someone does something more, they become more experienced, and their probability of success goes up. So we already have an optimistic calculation here, but the reality is even more optimistic than that. So I hope you enjoyed that, and till next time.